Every modern technology depends on microchips. Smartphones, artificial intelligence, supercomputers, even advanced weapons, but almost no one talks about the company that makes these chips possible. It doesn't design processors. It doesn't sell consumer electronics. Instead, it builds the machines that allow the world to manufacture the most advanced microchips, and only one company can build them: ASML. For decades, the semiconductor industry followed a simple pattern. Every few years, chips became smaller, faster, and more powerful. But shrinking transistors to just a few nanometers created a massive engineering problem. Traditional manufacturing technology simply could not print circuits that small. The entire industry needed a completely new type of machine. Without it, progress in computing would slow dramatically. And one company decided to attempt the impossible. In the early 2000s, ASML began developing a radical new technology called extreme ultraviolet lithography, or EUV. The idea was ambitious. Instead of using traditional light to print chip patterns, EUV would use light with an extremely short wavelength, allowing circuits to be printed with extraordinary precision. But EUV introduced enormous engineering challenges. The light source had to be created by firing powerful lasers at tiny droplets of molten tin. The entire process had to operate in a vacuum, and the mirrors used to guide the light had to be polished with atomic-level precision. For years, the project faced delays, technical failures, and enormous costs. Many experts believed it would never work, but ASML continued investing billions into the technology. And eventually, the gamble paid off. When EUV machines finally became operational, the semiconductor industry had no alternative. Advanced chip manufacturers quickly adopted the technology. TSMC used EUV to manufacture processors for Apple. Samsung used it for high-end mobile chips. Intel began integrating EUV into its most advanced production lines. Each machine is enormous. Some weigh more than 180 tons. They contain tens of thousands of precision components, and each system costs hundreds of millions of dollars. But despite the cost, companies must buy them, because no other technology can produce the world's most advanced chips. ASML's dominance does not come from a single invention. It comes from a highly specialized ecosystem. The mirrors inside the machines are produced by Zeiss in Germany. Laser systems come from advanced American suppliers. Many components require manufacturing precision measured in atoms. This global network took decades to develop. Recreating it would require massive investment, specialized knowledge, and years of experimentation. As a result, ASML has become one of the most strategically important companies in the semiconductor supply chain. Today, ASML sits at the center of the global semiconductor industry. Its machines determine which companies, and even which countries, can produce the most advanced chips. That is why governments have started treating this technology as a geopolitical asset. Export restrictions already limit sales of advanced machines to certain countries, and the competition for semiconductor leadership is only intensifying. Because in the modern world, economic and technological power increasingly depends on one thing: microchips. And those chips begin with machines built by ASML.